Hello and welcome. I'm Hullhound and today we'll be continuing on our Frogger clone. If you haven't already, I recommend starting from part 1, the link is in the description. So, in our last episode, we created the map, we created the game screen, structuring it to be the correct size, and we created the player character and enabled it to move. In this video, we'll be focusing on creating the vehicles that act as our obstacles and effectively our enemies. So let's get started. In much the same way that we did with our player character, we can start by creating a new node for our vehicle. So node 2D, we can rename this vehicle. This should be fairly familiar to you at this point. And then we will save scene, branch as scene, and we'll call it vehicle. Going into the scene, we'll have a blank canvas, similar to what we saw before. Again, continuing on, we'll create a sprite 2D, and we'll select the texture. So there's a variety of different images that we can use based off what Kenny's provided. I will pick one reasonably random. Wants to be a standard, like a land vehicle for what we're doing at the moment. So if I can not zoom in horribly. What we need to do is uncenter this in the same way that we did for our player character. And now we have a vehicle that's in the world. Now that we have a vehicle in the world, our next job is to make it move across the screen. So in Frogger, we have these 5 lanes of traffic, and then each lane has a different type of vehicle, and they're moving in opposite directions. So what we'll do is we'll start by going back into our vehicle scene and creating a new node. So what I'll just do is I'll go into scripts, file, new script. I'm going to call this automover 2D because we want them to move automatically in 2D. And we get our standard structure here that we'll have seen previously. So in order to move something automatically, we need to know by how fast it should move. So what we need to do is add in an export variable. So again, that's export, then var for variable, and then the name. So in this case, I'm just going to call it speed. And because it's the 2D node and I want this to be generic, I'm going to make this a vector 2D. So vector 2D basically represents a 2-dimensional construct. So it could be position, it could be speed, etc. So in this case, I'm just going to leave it like that, and we can populate that when we add it to our vehicle. Additionally, I'm going to add a export var for a target. In this case, it needs to be node 2D, as that's what I want to be moving depending on the speed. So nice and easy, all we're going to do is going to process, which runs every frame, and say the target's position should be plus equals, similar to what we used before, where it's the same value plus our additional value, speed. So although this does work, we have a slight problem here that some computers have a faster frame rate than others. Ideally, we want our game to run at least broadly the same on a fast computer and a slower computer. Otherwise, it gets really difficult for some users and it's not a consistent playing experience. But luckily, we have a value here called delta. And as you can see in the comment here, delta is the elapsed time since the previous frame. So effectively, this is how far through a frame we are. So the convention is that you times your speed by delta, and that way if you're on a fast computer, your delta is really low, so you may only move by a little bit. And if you're on a slower computer, your delta is quite high comparatively, and therefore you move by quite a lot. And over the time, it stays pretty comparable. We'll get rid of ready as we do not need it. So now, if we add a class name to this, so that we can select it on the right-hand side, So it is worth noting you don't have to do it this way, and you could just directly put it on a node, which I guess I will demonstrate. So if I just select a node now, what I can do is find my Automover 2D here, and I can just drag it on there. I don't need to do it in the way that I did where I'm selecting it from here. Which method you choose to use can vary depending on your preference. I will, however, now rename this Automover 2D, and I will set the properties. So in this case, I'm concerned about the vehicle, as that's what I want to move. And because our vehicle was pointing in the right-hand side, I want to give it a positive x speed. So I will just put you as 20. That's 20 pixels a second, roughly. 20 meters a second. And then we move along. That's nice and convenient. It's not too difficult. You may want to adjust these speeds later, but that will do for now. So now that we have a vehicle that is able to travel off the screen, what we'd like to be able to do is have it so that when it does leave the screen, it moves all the way back to the other side and then loops around, giving the illusion that there's more than one car. So in order to do this, we need to add a new node. So we go to the vehicle scene, go into scripts, and then create a new one. So in this case, I'm going to call it visibility offset 2D. And then I will adjust the code. So in comparison to our earlier nodes that we've made, we are not going to extend directly from node. Instead, I want to borrow some functionality that allows us to know whether or not we're on screen or not. And we do that by extending from the visible on-screen notifier 2D. What this does is it does what it says on the tin. It informs us whether or not something is visible on the screen or not. And it will inform us when that changes. So if I pressing Control and then clicking on the name, it will take you to the documentation. Here we can see all of the information about the node, including its properties, methods, and signals. So signals are a component of Godot that allows a node to indicate that something is changed in some way. So in this case, this node is telling us either an object has entered the screen or exited the screen. So we're interested in the screen exited. If we go back to our script, what we can do is we can hook in to this functionality so that our code knows when something is changed. In this case, the screen exited. So in that case, we can connect to ourselves because we're extending from this thing. So we have all that functionality ourselves in this node. And then we're looking at the screen exited signal, and then we connect to it. In this case, I'm going to make a function called move offset, and then I'll create a new function called move offset. And then what this will do is whenever the screen exited signal is called by this, we will then run move offset in our own code. In order to do something here, I need a few properties. So in much the same way what we've done in other scripts, we can add a target to say what we want to move. Just click it up. And we also need an offset amount, which is also a vector 2D, a vector 2, to match what we've seen in our Automover script. And it's a quick exercise. What do you think we have to write in here? Feel free to pause the video. Shimming you back. We can do target plus equals, and then, target position plus equals offset amount. And we don't need the process in this case. So what this will do is it will connect, wait for this object to go off screen, and then it will move the target by a certain amount. We would expect that this is linking to itself in some form, which is what we'll do here. So if we add in this, so we haven't given it a name as an indicator. So if I do class name, visibility offset 2D. So we'll notice something slightly different here. So when I select visibility offset 2D, we can see that the icon on the left is different. And the reason this icon is different from what we've previously had is because we're extending from another control that has a different icon, effectively, than otherwise. So if I had done what I did previously and had created a new node and then dragged the script on, I would get an error saying the node types aren't compatible. So I would instead have had to have selected this node type and then dragged the file on. But let's set this up. So assign vehicle as our target. And since we're moving to the right, I need to move left, so I need a negative number. And we know we've got 15 tiles times 16, so this will be a little bit too short, but we can use it as an example. 15 times 16, and just to get us there a bit quicker, I'll up the speed to 60. So if I now press F5, we should see our car move across the screen. And all going well, it should reappear there. And you can see that it appeared about here. So it needs probably another 2 lots of 16 in order to be at a good position. So in order to do that, I can write plus 2 times 16. And then all going to plan. I've accidentally done that the wrong way around. It's minus because it's a negative number. So 4 times 16. I'll try that again. It'll zoom off the screen. And then all going to plan, it will reappear from the right hand side. So having one vehicle is all well and good, but actually we need at least 5 different types in order to flesh out what we have for each lane. So rather than creating 5 different types of vehicles, what we can do is modify this one vehicle so that it has the properties that reflect each type of vehicle. So what we'll do here is we'll actually go into vehicle itself and we'll press the add script option, which will create as a vehicle script. What we're going to do here is effectively act as a go-between between all the other functionality that we have here and then whatever vehicle sits within. In this case, it'll be the level. So there's a few things that I need to make available. So in the first instance, we have export var. In this case, I want a texture. So we'll call it texture, and then it's texture 2D. So there are 2 ways that we can link this in. For the purpose of this tutorial, we'll keep it nice and simple. And we'll move from there. So I need to get access to sprite 2D. So there's a few ways I can do this. The easiest way is I can just write sprite 2D, which is the name, and then I can do dot texture. So what's it called? It's called texture, yeah. Texture equals texture. What this means is if I go into my level, select my vehicle, I select a different image here, so I can load, and then just as a quick test, we'll do something that clearly isn't a vehicle. Press F5. What we should see is a building moving across the screen. What you'll notice, however, is that it doesn't change here. We'll touch on that in a little bit. But let's first get it working the simple way, and we can go from there. So going back to our script, we also want to change the automover 2D properties and the visibility offset 2D properties. So in this case, export var speed vector 2, export var offset. We'll call it rotation offset vector 2. And then in much the same way, we can do auto 2D dot speed equals speed, and then visibility offset 2D dot offset amount equals rotation offset. Okay, now that we've got that all in place, let's give it a test to see how it goes. So I've set the speed to 100 and the rotation offset to minus 240, just so we can see what it actually looks like compared to what we already have. So you should see it goes faster. I want to check the image. It should go to middle of the screen-ish. Yeah, excellent. So those each work, and we can now customize the vehicle in a variety of different ways. So let's actually set those up to reflect what we want for the game. What we will do is I'm going to add some organization. So you can also use nodes just to make things a bit simpler. So I'm going to call these lanes. I'm going to say lane 1. I want this lane 1 to be down here. So I'm just going to set my transform to 15 times 13, 16 times 13, minus 32. And then we can add the vehicle into there. And we just need to offset its position so that it's on the line. 0, 0, and it then takes its parent's transform. So what I can do now is I can start by adjusting these so that it's an image I actually want. I'm actually going to do orange. No reason other than I prefer it. I'm just going to steal the figures that we had here. So minus 272. So it is worth noting here, I should have corrected this earlier, that the rectangle that our visibility offset has is not matching what we have for our character. So we can correct that by doing that and changing these to 16 by 16. And that now matches our 16 by 16 tile. We'll have slightly more accurate visibility offsets. Anyway, back to what I was saying. So I'll just set that to minus 272. And we'll set the speed to a nice round 40, I think. So we test that just to check that it does what we think it does. Excellent. And then I will duplicate these, pressing Control D. And I'm then going to set its transform, and I'm just going to move it along a little bit just to add a bit of additional position to what we have. Okay, now that we've set that up, let's give it a quick test. And here we can see that the vehicles are moving, and they're moving around, and they're moving at a different speed of a different image. So this is good. What we can do next is we can adjust it to set up the next lane, which is moving in the opposite direction. So what I'm going to do is I'm just going to create a lane 2. So add child node, node 2D, lane 2. I'm just going to copy one of the vehicles across, put it there, and I'm just going to move it up by 16. So minus 16 because we're moving closer to the origin, which is the top. And what I want to do here is flip the image so it's going in the opposite direction. So we've not currently put any support in for that in our vehicle. So let's do that now. If we move to our sprite 2D, we can see there is a property called flip H. And if we set that, it flips along the horizontal axis. Well, sorry, it flips horizontally, which means we are looking in the correct direction. So what we want to do is expose this property to the outside world. We're going to our script. So now that we're in the script, we can set up the property. So export var. In this case, we're going to call it flip H, and it's going to be a Boolean type. Boolean just means that it can be true or false, so it's a checkbox, which of course is what we're seeing in the inspector. So flip. Yeah, just not auto-correcting for me for some reason. So a 5. All well and good. Go to level, I select this one, press that. It should be moving backwards. Yes, but the rest of them are fine. So what I'll do is I will set this up. Let's go in the correct direction. I'll make the speed up a little bit. And we'll set that to be positive. So it moves from the left to the right. And I'm also going to change this image to something different. Let's go for this. And there we have it. So what I'll do is I'll just add 2 more of those. Give them a random X transform. I'll call you 200. And there we have something nice. So your challenge, our exercise, is to flesh out the remaining 3 lanes of traffic. So give that a go. It's following exactly the same process we've just gone through. So if you get stuck, just rewind the video, check what we've done, and go through it again. Welcome back. So if you've gone through the exercise, you should have something that's a little bit like this. You can see that each lane has alternating directions, different pictures for the vehicles, and different speeds. However, if you go off, you probably have something that's a bit like this, where all of the vehicles in the editor look the same. So what we can do is we can use the alternative method for setting these images so that it does in fact show in the editor as well. So to do that, we go to the vehicle script, and here we need to adjust what we have here. So what we need to do is, rather than setting this on ready, we need to add what's called a setter. So to do that, we add a colon, a new line, set value, another colon, and then effectively this is where we duplicate this line, but instead we use value, as that's what's coming in, rather than texture. What that will do is, if we save it, what we haven't done is set tool. So you need to set the tool keyword so that Godot knows that you need to action this script when you're in the editor as well. And there we have it. Just a quick additional piece, if you set a getter as well, then things behave a little bit nicer and you don't have to worry about pieces disappearing. So add the get, which is just get colon, and then return the sprite texture. Return just means take this value and pass it to whatever's requested it. That's it for this video. Remember to subscribe so that you can be notified when part 3 comes out.